Until recently, many researchers believed that another ice age, predictable in the near future, was looming over human civilization. However, everyone had long known by the 1980s that the opposite was true of the challenges facing humanity. The issue at hand is global warming. Hello, everyone. But is everything really that simple? Could it be that, in the end, what awaits our planet in the future is global cooling? Welcome, everyone, to our channel. That's what we're going to find out now. Let's get started. Global circulation and the greenhouse effect. As you may know, Earth is generally considered the only celestial body within the so-called habitable zone or life-habitable region of our solar system. In other words, it's a planet where surface water doesn't evaporate or freeze under the prevailing atmospheric pressure conditions, receiving just the right amount of sunlight from the sun. Strictly speaking, Mars is also within this habitable zone, and billions of years ago, it had water and even vast oceans. But today, there are significant challenges for water to exist there. In fact, the problem on Mars is not the temperature, but rather the atmosphere. Mars has such a thin atmosphere that water can boil and evaporate at what we'd consider room temperature. However, our discussion isn't about Mars this time. By the way, it's not just the sun that influences a planet's temperature. The composition of gases in the atmosphere is also crucial, including the presence of so-called greenhouse gases. These gases insulate the planet and are responsible for the greenhouse effect. You might be thinking of terms like carbon footprint, often mentioned by environmentalists. Many people have a very simplified view of past climate changes on Earth. They might think of eras like the time of the dinosaurs as very warm, followed by an ice age, a cold period, and then that era coming to an end. So, let's take a moment to reflect. How are past climate changes on Earth, up to recorded history, explained scientifically? When Earth was still young, its atmosphere was vastly different from today. It had very little oxygen and instead contained gases like carbon dioxide, methane, ammonia, and others formed during the planet's early formation. Methane, like carbon dioxide, is a greenhouse gas, but it has a much stronger greenhouse effect than carbon dioxide. So, despite the sun being weaker during Earth's youth, the planet was surprisingly warm during that time. About 2.5 billion years ago, the Great Oxygenation Event occurred. Oxygen levels significantly increased due to the activities of photosynthetic bacteria. This led to the oxidation of gases in the atmosphere, including methane. As a result, the greenhouse effect weakened, and Earth truly froze for the first time. The Huronian glaciation began. For about 300 million years, our planet was covered in endless glaciers, reaching as far as the equator. Afterward, Earth thawed, but cyclical temperature fluctuations continued. Extremely cold periods occurred, for instance, during the Cryogenian period, around 720 to 635 million years ago. On the other hand, periods like the Carboniferous, famous for giant insects, and the Cretaceous, when dinosaurs thrived, were generally warm. Those times even saw lush jungles at the polar regions. The causes of cooling and warming are indeed diverse. Natural conditions untouched by human influence can also lead to the release of substantial greenhouse gases. For example, supervolcanic eruptions can result in drastic changes in climate and the movement of tectonic plates. This alters continent shapes, which in turn means changes in ocean currents. Such shifts can influence the release and circulation of warm and cold ocean currents. The unfinished ice age. Now that we've delved into ancient geological eras, let's shift our focus to the current geological age. You've probably heard about the ice age our ancestors endured, a time of harsh, icy conditions. It was a truly challenging era. At its most severe, ice covered what is now Poland and Germany entirely, as well as substantial parts of France extending into the Alps. This ice age came to an end around 20,000 years ago. At least, that is what we believe now. However, the truth is, the ice age hasn't really ended. The most recent ice age is just a part of the much longer Cenozoic era, which began about 40 million years ago. Researchers believe this ice age began when the Antarctic continent finally separated from the Australian and South American continents. The formation of the Drake Passage created a vast oceanic gap between Antarctica and South America, allowing a cold current to flow around the entire continent's coast. This caused Antarctica to become ice-covered, effectively serving as Earth's air conditioner on a global scale. The era we're living in now is merely a temporary warm spell, and it's highly unstable. Looking back through history, you'll find that climate has varied between warm and cold periods. For instance, during the time of the Roman Empire's conquest of what's now the UK, vineyards thrived there. But today, foggy Great Britain is not a suitable region for grape cultivation. Overall, despite the current trend of warming, the average global temperature of our era is still relatively low, around 15 degrees Celsius. Compare that to the Cretaceous period, when Earth's average temperature was approximately 27 degrees Celsius. Currently, for the first time in Earth's geological history, humans are influencing the climate. Our era was already experiencing a warming trend, but the escalation of human emissions of greenhouse gases has threatened to take it to uncontrollable levels. But is there no turning back? As mentioned earlier, during several geological eras, Earth was much warmer than today. Even considering human emissions, carbon dioxide levels were higher in the past than they are today. However, life on Earth didn't disappear because of it, and the major cycles of cooling and warming continued. Let's take a moment to imagine the most severe scenario if catastrophic events were triggered by global warming. Imagine average temperatures rising over time, causing even the Antarctic ice sheet to melt, revealing the Antarctic continent for the first time in millions of years. This would lead to a significant rise in sea levels worldwide, submerging vast coastal areas. These regions include major centers of human technological civilization, like the coastal areas of the United States, China, Japan, and South Korea. They would suffer immense damage, and in some cases, they might disappear altogether. But Earth and life on Earth won't vanish. Eventually, for various reasons, such as the movement of tectonic plates mentioned earlier, another ice age will come sooner or later before the next warming. So, even if we experience the hottest point of global warming, Earth might turn into a snowball again. Geological plate movements and volcanic activity play a role here too. Our Earth, being quite aged, won't get hotter deep inside its core. In a few 100 million years, the Earth's interior will cool entirely, potentially causing a complete halt in plate tectonic movements. If that happens, the natural release of greenhouse gases into the atmosphere will cease. In essence, the Earth's internal heat, which has kept the planet warm, will no longer be available. As if to compensate, the sun's rays will intensify. If these rays can't sufficiently warm the Earth, we might face another severe ice age, similar to the one that began after the Great Oxygenation Event. It's time to wrap up this video. Thank you all for watching. I hope you've enjoyed this video. It seems that life on Earth may have started to become what we know during ice ages, and it might also come to an end during an ice age. If you've enjoyed this video, please give it a thumbs up. And don't forget to share it on social media. You are our only support to keep making videos. Thank you for your warm support as always. Well then, it's time to say goodbye for a while. See you again soon, everyone. Goodbye.